My name is Ishwar Parulkar. I'm going to talk about Cisco's ASR 901, which is an advanced services router for 2G, 3G, 4G, LTE, and in the mobile backhaul space. So just to give a little context on the product, just one second. I just wanted to spend a minute giving a little bit of a context for the product. So Cisco's been around in India since 1998, but it's evolved from a handful of engineers to getting more and more component ownership, managing, sustaining platforms, starting a globalization center where we start. Yeah. Okay. There was a point. Sorry, the point I was trying to make was this was the first product that we completely conceived and executed or implemented and marketed from here. So the point of this slide was that. So there's a lot of engineering, but this was the first product that came out of this site. So we all know that the mobile internet is growing fast, but based on our networking index, we are seeing really staggering numbers by 2015. There's a whole number of billions of mobile connections. There's enhanced computing. We have more and more powerful devices. The data rates are getting faster, and there's rich media content. So, from in a period of 5 years, from 2010 to 15, we're expecting like a 26-fold growth, and it's kind of on track there. Of course, the opportunity in the developing markets is even more attractive. Again, these numbers are familiar to most of the people here. The point I wanted to make here is the number of cell sites in this part of the region is much higher than and expected to grow higher than other parts of the world, as well as the capex that the service providers are spending is almost the growth in the capex being spent by service providers is almost twice in this part of the world. So here's a network topology diagram which kind of shows where this product fits. So you have on the left, you will see the cell tower. So it can be a 2G, 3G, or a 4G tower. And the ASR 901 sits next to the cell tower, and it aggregates Ethernet or TDM traffic over the metro ring that you see, and backhauls it onto the edge and core of the network. Right. So that's its primary job. It sits on the metro ring. These are typically a few cell towers in metro areas. And of course, the reverse part where you get data from the core and the edge, it kind of sends it back to the subscribers. So this is its key position in the network. It has slightly different applications depending on business premises and cell towers and the topology of the metro rings that the service providers use. This slide over here gives an overview of what the box looks like. So it's a very compact router. Compact in the sense it is a 1RU and ETSI compliant. It has extremely low power. This is one of the big differentiating features of this. So if you see the feature set it supports and the kind of capabilities it has, 35, 45 watts is kind of a paltry number. So that's one of the major things we're focused on is building a low power router. And then it's hardened. It has 12 gig Ethernet ports and 16 event. So it has both TDM and Ethernet support. And there's a whole bunch of features, L2, L3, MPLS, IPv6. I won't go into the details of that. I'll speak to this, a couple of these in the coming slides. And then there are several network timing modalities, synchronous Ethernet, 1588v2. So it's pretty exhaustive in the timing domain. That's another key feature of the box. There are different variants with different kinds of ports. I've shown two variants here. There's another variant which adds 10 gig Ethernet capability. So they're basically based on the same architecture and fundamentally hardware and slight software variants of the main platform. So there are several innovations in this product, and it's obviously hard to speak to all of them in 15 minutes. But I'm going to give you a flavor of some of them. And if you look at the innovations in this box, there's like a few dimensions to the innovations. And the three key from a technology perspective are advancing the state of the art in mobile backhaul. So we have some features and capabilities which advance the state of the art in mobile backhaul technology. The second category is frugal innovation. So we've concentrated on focused very aggressively on seeing how we can keep the cost and the power low. So it's an excellent example of frugal engineering, and there were several ideas that we worked out in coming up with this low cost and very power efficient product. The third one is reverse innovation, and this is kind of a unique case of the classic reverse innovation, where we started with looking at what we could do for the emerging markets, and it's ended up being a very attractive, competitive global product with most of our customers in the developed markets now. The other interesting artifact of the development exercise was we worked on developing an end-to-end ecosystem that's required in India to build a product like this from scratch, from silicon to hardware platform to software to qualifying the product for global telecom certifications to the software management layer. So we built the whole ecosystem here in delivering this product. So let me take you a little through the first one. So there's a whole bunch of features in this product. So there's L2 switching, L3 routing. There's MPLS, that's multi-protocol label switching. It's basically a protocol where you can put labels on top of IP addresses so that you can do a quick lookup. You don't have to look at the whole IP address to route packets. And the advantage of this protocol is that you can have any underlying layer 2 technology. It could be SONET, ATM, but still you can encapsulate the frames in MPLS and then do a quick routing of the table just looking at the labels. So that's it's a technology that's evolving, and the key contribution here is that we have brought it to the cell site portion of the network. HQoS is hierarchical quality of service, so it's just a more finer granular quality of service where you can prioritize traffic and route it accordingly. The other key thing is IPv6. As we're running out of addresses, IPv6 is becoming more common in networks. But this is, again, we believe, the first product in this space to really be fully IPv6 capable. And IPv6 has implications on all of these features, right? So there's a whole bunch of effort that's gone into making this IPv6 compliant. So a lot of these are technologies that everybody's working on, and they're part of standards, and as a company we do a lot. But the main challenge here was to how do you cram so much of features in an efficient cost power footprint in this cell site router. So we use silicon, and we co-developed this with a silicon partner, and we had to live with constrained resources in terms of table types and sizes. So all of these things share. These features share all of these tables, and essentially what we build internally is a software resource management layer where we optimally allocated table entries. In some cases, we extended the table functionality to handle additional features to ensure that we were able to meet this rich, complex next generation feature set at line rate. So all of these features work at line rate, giving the scale that's needed for this. And the flexibility of having more L3 VPNs versus something else, trading those things off. So it's a very flexible, configurable kind of an architecture where you can repartition the use of these resources to achieve these multiple features. Another example of advancing the state of the art in mobile backhaul is IEEE 1588v2 or precision timing protocol. So this is a network timing protocol that's becoming more and more, it's becoming a need and becoming more acceptable in terms of deploying networks as a technology moving forward. Essentially, the timing is carried through packets here. So when you move from one cell tower to another, you don't drop calls. You need that high level of accuracy between cell sites. And the basic premise here is there's this is the basic switch. There's a PTP processor which processes these timing packets and generates a clock. But the challenge here is that you have a very expensive crystal oscillator. That's the OCXO that's shown here. And the design of this is very complicated because it depends on two variables. One is the variability in the network, which means that your packets come at different times. And then there's the OCXO, which is very sensitive to temperature. So we came up with a way of, the typically conservative design point is to use expensive OCXO to kind of meet the network variability. What we came up with was an optimized design point which allows us to use a very cheap oscillator, right? So that's one thing. The other thing was we optimized the software stack so that you need, you can run all of the processing in one processor. You don't need multiple processors, a control plane and a special processor for that. So I'm just going to go to the frugal innovation part. So this is one example of frugal innovation where typically these products have very complex power modules which have which meet high telecom standards of EMC, reliability, etc. But they're large and expensive. Off-the-shelf ones are cheap, but they don't meet this high reliability standards and EMC compliance standards. What we designed was a combination of the two. So we took the off-the-shelf components and modified them, worked with the vendors and on the board to kind of fit it in the compact form factor. In terms of reverse innovation, this is another thing I wanted to cover. And this captures a bunch of innovation. So we started with requirements critical in emerging countries. Low capex and opex. We wanted to protect legacy investment in 2G voice, sustaining harsh and unreliable environments, and rapid scale. So once you deploy, you want to scale very rapidly. And we achieved that by focusing aggressively on cost, feature optimization, and low power. We have added TDM interfaces to protect the legacy environment, its extended temperature range, and there's a pay-as-you-grow feature set model. But at the same time, it has next-generation cell technology. It's 4G LD capable, it has MPLS, MPLS-TP, advanced timing, and so forth. So essentially, with a combination of the two, we have a very competitive global product. And this is kind of an interesting case of reverse innovation from that respect. Lastly, just quickly, I wanted to touch on local ecosystem. So one of the challenges we had in developing this was having all the pieces here. So it's a complete product that was developed from here. So silicon partners to platform to compliance testing to software and network management layers. So we did a fair bit of enablement of the local ecosystem in building this product in terms of building capability, doing co-development with the partners, as well as knowledge transfer. So one of the things is, telecom certification is very different in different parts of the world, and we worked with the qualification labs here to bring that capability and transfer that knowledge here so that more products like this could be built out of here. So it was a challenge, but it was also something that we were able to enable in the development of the product. So essentially, what we have here is a very powerful advanced services router, multiple access deployment scenarios, 2G to LTE, and we, as I mentioned, conceived for the Indian market, but it's a global product, and we have several customer wins in USA and Europe, and it has several advanced technologies, timing, MPLS, IPv6 are the most notable, and we brought some of this L3 and MPLS technology right up to the cell site in this product. So that's all I had. If you had any questions.
This looks excellent and very strong product for IP and Ethernet, but the application, the target application what you have is for BTS, and there is still a large space required for SDH, PDH. Do we have those interfaces available here?
No, so we have TDM interfaces. We have event-event interfaces. Yeah, that's what we have.
So still there is a need for a box to be positioned there.
Yeah. So there's certainly that need, and in the future there could be more integration of that, right? So, but you're right. I mean, there's some more.
I have 2 or 3 questions which are completely non-engineering. First of all, the way you presented it, it seems like the innovation being of a frugal and reverse nature has a certain ad hoc quality. So the big question is this interoperability sustainable in terms of evolution? So once it is, how scalable it is in terms of for future purposes, or is it just serving a product need from a vendor, customers at this particular point in time? You know, if they were to look back 2 years hence, would they consider the investment worthwhile in that sense? As a logical, I'd also like you to explain in economic terms or something in terms of what this generation represents vis-a-vis either your competitors or your own products 2 years ago in terms of number of people being used to deploy or service, in terms of number of, the cost element or anything. If you can throw some light on that, that'll be nice. Thanks.
So the first question was on the ad hoc nature of the frugal reverse part and how scalable it is, right? It wasn't as ad hoc as it might seem. The reverse innovation part happened gradually, in the sense we started with these requirements, but in the middle of the project, we realized as a company and as well as the team that this had much more potential, and we consciously incorporated some of the developed market requirements, right? So this was in the middle. We realized we had 90% of it. If we did one or two things differently, it would fit a bigger portfolio. So that was regarding the reverse innovation. And on the frugal part, it wasn't ad hoc in the sense that was the main goal. We targeted cost and power very aggressively. So each architectural and implementation decision was questioned and revisited in terms of what are the different options, how can we do it differently. And we have institutionalized some of these processes and technologies within the company. Like the power supply design is an example. It came from this, but now it's a standard way we are designing power supplies for many other products. So from a scale perspective, because of this, it's very scalable in the sense that we are already working on variants which scale to the next generation using the same architecture and in many cases the same module or the same piece of the design. So your second question was
economics that you could share with us, in terms
the
of
team?
cost elements, or how much does this box compare with or its previous generation?
Yeah, so again, that's a very good question. So we had set a target of being half or less than half of the previous generation box, which is of course much lower performance and less featured than this. And we ended up about 1/3 of the cost of what the earlier generation box is. So that's pretty significant. Power-wise, if you look at the nearest competition in this space, we are a little under half of the power. So if you look at competitors' boxes or similar boxes, they are at about 80 watts, and we are at about 35 for the smaller SKU and 40-45 for the larger SKU. And within the previous generation product also, we are a little under half in power. So.